All right, do you see this schematic in front of you? It's got this big black chip in the middle, looks like a spider, and it has a bunch of electronic circuits around it. Are we looking at that screen?
Is it CPU? No.
Oh, what was the
Yes, we
question?
are.
Yeah, so who asked the question?
Is that CPU?
Is that a CPU?
That's
It's a
not
little,
load salmon.
okay, it is a microprocessor. It's not a CPU. So a CPU
I love
is
those
a central
sounds.
processing unit. It's very similar to a CPU, but it is a chip. And it happens to be an 8-pin chip. This particular chip is a very famous, it's called the 555 timer. And the 555 timer as a integrated circuit, it's like a little, I don't want to say it's like a little computer because it's not quite that sophisticated, but it is a integrated circuit, has a lot of components on the inside, bunch of transistors, resistors, diodes, and it's all packaged into a little tiny 8-pin chip. It's a very popular chip that's used for many, many different kinds of circuits. And so one of the very first exercises that we're going to have you do is to work with this particular circuit. And let me bring this over to one side here, bring this over to this side of the screen, bring this up to here because I need to have MultiSIM running in the background. So I will go ahead and engage this and go to here. Go to here. Okay, so you won't be working with this as we're discussing things. So just follow along the tutorial. I'm going to open up MultiSIM in a moment. And here's the file that I want. So you will see directions similar to this. You'll have the 555 flasher schematic, which is on this side of the screen, and you'll be given a basic MultiSIM file. The basic MultiSIM file you can download, and when I open this download, it'll open up MultiSIM. So MultiSIM is opening on my computer now. And what I'm going to do is, while that's opening up, I'm going to shrink this up a little bit more because I need more of my desktop space to demonstrate MultiSIM working. We only need a portion of this visible for us. Okay, here's my MultiSIM. And yes, this is fine. I can move the chat out of the way. Back to this screen. All right, and let me go ahead and change the view. Zoom in and zoom in. Zoom in. I think that's pretty large. Maybe I can zoom in one more time. Let's try this. And zoom in. Boom. Nice. Okay, I think this is plenty for us to work with. So what you see here, when you go to open up a file that I will be making available to you, is all of these components are already placed in the file. All you have to do in this first MultiSIM exercise is connect the wires. So you have to make the wire connections to look like this guy here. And let me explain this particular circuit so you can understand better what we're going to do in the connections. What we have are LEDs. So there's a pair of red LEDs called LED 1 and LED 3. Those are red ones. And there's another pair of LEDs here. And this pair of LEDs is listed as LED 2 and LED 4. And these guys are green LEDs. Above each of the LEDs happens to be a 240 ohm resistor. What's the purpose of the 240 ohm resistor? It's called current limiting. We have to make sure that our LEDs don't burn out. And so there has to be some kind of a resistor to keep the current under control so the LEDs don't burn out. So if you remember the very first circuits we built together in many weeks ago, your circuits contained LEDs for two reasons. The primary reason for containing the LED was to show you that, yes, the circuit was built properly, because if it lit up, it was in the current path, and it gave you a visual cue that something was hooked up correctly. But in conjunction with the LEDs had to be resistors, and the resistors were there to keep the LEDs from burning out. So how do I make this part of the schematic look like this part of my schematic over here? Well, let's start with the voltage source. Voltage source is always the best place to start. I have what polarity on top of the voltage source? It's long plate, so it must be what? Positive. Good. And then the lower plate is? Negative. So take a look at the negative plate. The negative plate is attached to jumper number 2 to the bottom of these two capacitors. It's attached to ground, and then it's also attached to the bottom of these LEDs. So there's a lot of things at the bottom circuit that this is connected to. So what I'm going to do is I'm going to come over here, and I'm going to move this ground a little lower because it's really awkward where it's at. And I'm going to connect this, if I can help see that part of the screen, which is hard for me right now. Bring this over and up. And I will take this guy and make a connection here. Click. I have to make a click. Click, and there should be a dot. Click. Is there going to be a dot here? Or it's going to click over here. Okay. If it doesn't click at the bottom of the component, make sure there's a node that somehow attaches near the component. This ground wire, click on here and bring it up to the wire and click, and it will create a wire connection there. So do I have the ground connected from, do I have the bottom of the voltage source connected to ground to these components on the far side? And is that one of the things that needs to happen according to our schematic? Come on, mouse.
Yes. A question, why would you put a ground right in that area if you have negative on the battery terminal?
It simply serves as a common reference point. That is not an earth ground. So it is used only as a reference point. And when we get more into Kirchhoff's voltage law and Kirchhoff's analysis, that ground will be, the usefulness of the ground will be more evident to you all. So for now, think of ground not as earth ground, but think of ground only as a common reference point, which means anytime we do any polarity measurements of voltages, the negative lead of the voltmeter will always be measured down to this point, okay? So that's here solely as a reference point. It is not connected to earth ground. Now, what else is connected to the bottom of the circuit? So I have those two LEDs connected to ground to the negative side. I have these two capacitors and this jumper wire to connect to the same rail. So I will do that here. You move your mouse pointer to the bottom of C1, and you notice it changes from an arrowhead to a dot. When it changes to a dot, you click, and then you bring that wire down. Now, note, if I go here, with my cursor, with my mouse, the wire will follow. I don't want to go anywhere other than down to this wire. When I'm down here, click again, and it will create a node to assure you that you have an electrical connection. Now, my mouse will come up to C2. It's an arrowhead. When I come up to C2, it changes to a click here, pull the wire down to here, and click. Oop, I have to click, and then a node is formed. Jumper wire number 2, click, bring this down, and click on there, and I have, so on the negative side of the voltage source, I have jumper wire 2, C2, C1, and these two LEDs on the far side.
What are jumper wires for testing?
Jumper wires will be used, they're a placeholder for an actual circuit that I'm having another class build. So in my 51 class, they're building this circuit for real, And there are jumper wires that are part of that circuit. And so they're shown here in the schematic where the jumper wires are physically going to go. So for our purposes, we're not going to use the jumper wires. They happen to be part of a physical lab kit project that my other class is building, okay? Jumper wires are typically used as measuring points. And so to answer your question, on J1 and J2, instead of this fictitious 5-volt source, my class will be using a 9-volt battery between J1 and J2, okay? And that physically exists on their circuit boards that they're building. But they will have no purpose for us other than just being part of this drawing. Now let's go ahead and continue with this. If you take a look, do I have these current limiting resistors hooked up to the LEDs? So all I have to do is come over here, is come up to the R6, click, and click to there, come to R3, click, and pull the wire, click to there. Now I have electronically connected those. Let me go ahead and do the same here, click here, and R4, click, and here. So now the resistors and LEDs are hooked up together. Let's see what's happening on the top side of the circuit. On the top side of the circuit, I've got positive 5 volts coming out, and it's got to connect to the top of this voltage series resistor arrangement, and then it connects to 4 and 5. So I'm going to do that here. I'm going to take my voltage source. Again, this changes from an arrowhead to a black dot. Come up here and bring this over to here and connect there, and bring this and connect there, and bring this and connect there, and bring the jumper wire number 1 and connect there. So the top of the voltage source connects to J1, R1, R4, and R5. Do we have the top connected to J1, R1, R4, and R5? So far, so good. There's another wire coming down from here to the first pin of U1. So we're going to do that. Pin 1 of the first pin on the right-hand side of U1. The mouse is presently an arrowhead. When I come up to that pin, it changes to a black dot. And as a black dot, I can click, click, bring it up, and click again. And now I have that connection that matches this wire here. Are we good with everything connected to the top so far? There's one more wire that connects up here, and that happens to come from the 4th pin on the left. It comes down and comes up to here. So let's go ahead and do that. So the way you do that is you make your mouse pointer come to this pin. It becomes a black dot. Come over 1, let go, click and come down, let go, click and come over to here, let go, click again, come up to here, and click in place. Now that wire is moving as we want it to. Then we also happen to have our 1 and 2 hooked up together, hooked up to the top of C1. So let's go ahead and make that happen. So here, down to here, here, down to here. Now those are connected. C2 is not hooked up to those resistors. C2 is hooked up onto the first pin on the left of the timer. So I'm going to bring that wire in. So the mouse, black dot, click, pull it out, click, come down, click. Now that wire is in place. So far, so good. Okay. Now, something has to happen further. How do these LEDs hook up together, or do they hook up together? So if you look at the schematic, on the 2nd pin on the right, there's a wire coming out, and it connects the bottom of these 2 LEDs to the top of these resistors. So that is one giant connection. That is a huge node. That node has one wire coming in, one wire here, one wire here, one wire here, one wire here. That's 5 wires all connected together into that pin. So I'm going to do the same this way. Let's go ahead, come to this pin, click, and pull it. Wait for the dot. I have to wait for the dot. Click. Okay, over here, hover and down. There. Take this resistor, hover, click. Take this here, click. Take this guy here, click. So on the second pin on the right side of the chip, I have it hooked up to L1, L3, R3, R6. Is that what we wanted in this drawing? Yes. Next, there happens to be a wire that connects all of these on the negative side of this. Something from this rail has to come up and connect to the fourth pin on the right-hand side of this chip. See this wire right here? I have to make a connection to my ground wire. So I will come up here, click, come over, click, come down, click. Have I established that wire? From here, it connects with the bottom of the circuit. Everything is good. All right, one more pin on this side I have to deal with, yes? On the right side of the chip, I happen to have pin 3. It comes down, goes over, and comes up to a wire. I don't happen to have this wire in place. This is a wire from pin 2 on the left-hand side that connects between R1 and C1. Let me put that little wire in place first. From here, click and click. So now I have that one wire from pin 2 to this string of R2 and C1. There's the wire right there. Now attached to that wire is got to be a little wire that comes around and goes to pin 3 on this side, this guy right here. So now I have something to attach it to. I'm going to come here, click, come down, click, come over, click, come up, and click. Now I have this from pin 3 all the way up to pin 2 on the other side. So pin 3 on the right, all the way to this jumper wire, which connects to pin 2 over here. One more wire to go, because I've got one more leg of the chip not connected yet. So pin 3 on the left has to connect to the point between R1 and R2. So let's go ahead and do that. Click. Up to here, click. Come up to here, click. Come over to here and click. Okay, now let's take a look at our schematic and see if it is wired as we desired. Come on, mouse. We go. Okay, so let's analyze the right-hand side of the circuit. On the right-hand side of the circuit, positive side of the source has a wire going down to the first pin of the chip. I have the positive side of the source wire down to the first pin on the right-hand side of the chip. On the right-hand side of the power source, I have R4 and R5 connected to the top. I have R4 and R5 connected to the top. R4 is connected to the first LED, R5 is connected to this LED. Those connections are here and here. Then the bottom of these LEDs connects to the top of these resistors. I have the bottom of these LEDs connected to the top of these resistors. And these 4 components are connected to the second pin of the chip on the right-hand side. These 4 components are connected to the second pin of the chip on the right-hand side. The bottom lower portion of the circuit shows the resistors connected to the LEDs below them, and on the bottom of the LEDs are connected to the negative side of the source, which is attached to ground. Over here, the resistor is connected to an LED, the resistor is connected to an LED, and the bottom of these LEDs are connected to the negative side of the source, which is attached to ground. There is a jumper wire from this ground wire up to pin 4 on the right-hand side. Is that evident here? Here's the wire from the ground up through pin 4 on the right-hand side. The only thing left to analyze on the right-hand side of that chip is the third pin down. The third pin down comes over, comes down, over to here, and up to a jumper wire, and that jumper wire takes us to pin 2 on the left-hand side and the junction between R2 and C1. Here's that jumper wire, pin 3 on the right, coming down, over, connects to a jumper wire, which forms a union between pin 2 on the left and the point between R2 and C1. Those wires are in place. As we go to analyze the other side, see if I can separate this. Here and okay. So as I go to analyze what's happening on the left-hand side, voltage source comes up to jumper wire 1. Voltage source makes a connection to R1. So here, voltage source, jumper wire 1, R1, and there is one jumper that comes down here and connects to where? Pin 4 on the left-hand side of the chip. Do I have a wire from here down to pin 4 on the left-hand side of the chip? Yes, I do. And then the bottom of C1 and C2 connect to the ground wire, to jumper wire number 2, back to the negative side of the source. On my schematic of my diagram, bottom of C1 and C2 connect to the ground wire, to test point 1 wire, to the negative side of the source. Do you feel that we have covered all of the necessary wires that are shown in the drawing in our MultiSIM? Yay.
Yeah.
All right, so what else is left to do to make sure this guy is working? There happens to be, well, we should do this. A long time ago, we should have done this, sorry. File, save as. Should actually save it much sooner. Save it to an appropriate destination. I will go ahead and save it to our 50 folder. And this will be labeled first name underscore last name underscore 555 underscore flasher underscore wiring underscore today's date. 15. And I'm going to copy this. So again, your last name underscore first underscore 555 underscore flasher underscore wiring underscore today's date. And then you hit save. Now, we're also going to bring in a text box. So we're going to place, so look at your menu structure. Place is a pull down. And I'm going to place a text box. So I'm going to go to text. I'm going to click text. And then somewhere on, I'm going to click, and it forms a text box. And I'm going to paste the title that I had created a moment earlier because I copied it. And I'm going to make it a little bigger, 14-point size, and physically move this over to here. Nice. So now you have a label. So the label as the file name should be last name underscore first name underscore 555 underscore flasher underscore wiring. Now we're going to save this one more time. So file save, because it now has your information on it. Now we're going to run it and see if the thing works. So there happens to be a little green triangle called run. You click it. And what will happen is it'll energize the circuit. And then in a moment, this thing will start working. What LEDs are lit in my drawing right now, my schematic? It shows the green LEDs lit. And in a moment, I'm not going to do anything. In a moment, the timer through the resistor and capacitor will switch over from green to red. And it's taking a while because the capacitor is such a large capacitor. Now, did it change? From green to red. Now are the red LEDs lit? What happened to the green LEDs? They went off. And in a moment, This will switch back in a long moment. There, it switched back. All right. I need to put stop on this because you need to make one adjustment. Stop. You can't make adjustments unless the simulation has stopped. You need to come over here to C1. You need to double click it, and the dialog box will come up for its characteristics. Right there, it's a 10 microfarad, 10U. You need to change this from 10U to 1U. So 1U, 1 microfarad, because it'll flash much faster. Hit OK. Now it's a 1 microfarad capacitor. I'm going to File, Save. Now, when I run this, look at the rate of change between the red and the green LEDs. Are they now flashing more quickly, alternating between red and green, red and green, and red and green? This is the file with the capacitor changed to 1 microfarad, your name on it, that you're going to need to turn in as your first multi-sim exercise. And before you can turn it in, you also have to make sure it's off. So you have to stop the simulation. So you're not going to send me a screen snip of this. You're going to send me the actual multi-sim file because I need to see it operating with the blinking as it's supposed to be blinking, and that everything is working properly. Okay, a screen snip is insufficient for the multi-sim at this point. Any questions about the multi-sim, your first multi-sim exercise? Christian, Pauline, Gabriel, Rolando, Andrew, Wenbin, any questions about this exercise?